what we want to do is, instead of just actually, let's see this a little bit. The way the requirement, the way the CI checks look is like this. So if you open a pull request, they will run through. This could be, in this case, what we use, but you can also use Jenkins, Travis, whatever you want to use. The way it looks when you do inline editing is basically this. And what you can also do is, here we can see, for instance, that Arthur's colleague, TMA, his name is Thomas, he actually approved these changes. So also, in order for something to be merged back into master, you can add certain requirements in order for this they just need to happen. So you can say at least the manager level has to do this, or you need 3 peer reviews, etc. So, and if you're already falling asleep now, this is the moment to pay attention because the next question is coming up. So we're now looking into a pull request that Arthur has actually been working on. It's already closed, so the requirement checks that ran through look a little bit different here, so don't be confused. But there's a couple of things that we want to stress and that we want to show you, because earlier we talked about how actually at GitHub it's very important for us not to send emails. Because I mentioned that we also have the code history within the pull request. And this is really important because we have a whole big team of about 300 engineers working on code at GitHub. So that means we have to loop people in, and also sometimes we can't wait for 24 hours until someone in the time zone again wakes up after he already went home. But we have teams all over, and that's nice, and we want to leverage that. So what has been done here by Arthur actually is he described what he'd done, what the pull request is about, and he pinged several teams as well as some individuals that he wants to have feedback from. And then you can see there's a whole discussion going on. So he already got a party emoji because someone finds this really amazing. And you can see at each point what actually happened, right? So they can ping him with an add mention again, and you can see once this has been merged back into master, for instance, as well. So now, next question. If you look at your GitHub right now, what do you see as different? I'll give you a little hint, it's at the top of the page. It's the black bar on the top? Yeah, perfect. That's exactly what I wanted to do. So come to me after and you'll get an AutoCAD. So what I want to show you about this, we've been talking about performance and how nothing is shipped until it's fast. So every employee at GitHub can actually see the performance on the side at this point. We can also see which branch is actually in production right now. And we're going to jump back into the presentation where we are actually at the shipping point. And this is really important for us because we actually ship about 500 times a week. So what we do with 49 million users on the side, we need to be able that if there is a mistake, even though we check everything, to be able to jump back into the latest working version. So we actually deploy from our feature branch, in this case, my branch. And then if there is a problem, we can go back to the master really quickly. If everything works, we merge them back together after the deploy. And actually, Arthur is going to tell you a little bit more about how we do the deployment.
Yeah. So at GitHub, we usually deploy in 3 stages. We do a deployment to an environment called Regulab, which is pretty nice. It's a dynamic environment which gets created when you do a deployment. And we can have infinite amounts of those environments. So if I have a branch like this, the pull request that you've seen before, and I want to try it out in production, not locally in my development machine, I do a deployment to Regulab that will spawn out a new GitHub instance, running a production database, but being otherwise completely isolated. And then I get a specific URL based on my branch name where I can go to. I can also send it to other people in my team, and we can play around and see if everything is good. Next stage usually is a deployment to Canary, which is actually production, but it's not all of production. We deploy to 12 servers first, or 30, I don't know, something like that. We just select a random set of front-end API and backend servers and deploy a branch there. And we can then check where everything is still working fine. And if that checks or that passes, like everything is good, we don't see any major issues coming up, then we deploy to everything, to every other server on production. And then we do the merge. Another thing is, look, we try to revert and merge in Git. Did you have fun? Like, did you get it to merge actually? Like, it's super hard to revert and merge correctly, especially if other verbs already happened. So that's why we do the merge again. This is a chart showing how many deployments we just had last week. And last week was a bit sleepy. We had another conference where a lot of engineers were attending, like our own company conference. So we had 360 deployments last week, right? That's a lot. The company where I worked before, we had, like these are production deployments. We had one production deployment in 3 months, so that's a huge difference. And I want to talk about two of the more technical things which allow us to make those many deployments a week. One thing is feature totals. Who has heard of feature totals before? Who is actually using them for deployment? Maybe 5 people, 10. So we use feature totals a lot. The idea behind feature totals is that you can write a new feature, deploy it to production, and no one will see it. That's great, because you can write code, merge it early, deploy it to production early, and then enable it for specific users, or specific repositories, or specific organizations. And we can try out new features within like our team on GitHub, but no one else is going to see them. I think that we can ship very often. We can ship things while they're not ready yet, while either the design is not there yet, or some feature class will missing. And that's also kind of comes back to this idea that non-blocking is better than blocking. We can ship while not actually shipping to everyone. And like this is how this looks in code. This is pretty basic. We can, as I mentioned before, we can check where a feature, like my awesome feature here, is enabled for a specific user if we have the user logged in, or we can check if that is, if you're looking at a repo, if that feature is enabled on that repo. So pretty basic. We also have a UI where we can toggle these chip-like features on the fly very easily. So you can see here this feature, which I blurred out because it's super secret. It was enabled or is enabled right now for 4 people. Those 4 people are all in the same team, so they're working on a new feature and they're only testing it on themselves. Like everyone else doesn't see it. And it's actually, okay, everyone else inside GitHub, like with working at GitHub, actually has access to it because it's also enabled for people in the previous feature. We also have more options here that you can see, like dark shipping, which we use for things where we want to do performance tests, right? So we enable it, we create a feature, we wrap some new code that we want to add inside this feature called a block, or inside like an if feature is enabled block, and then we deploy the code, and then we slowly increase the dark shipping thing. And then we can, for example, performance measures, right? If you're working with this new feature, it's sometimes really hard to understand performance impact, especially at like the large size that we operate. Like if you have, I don't know, 20 million users, it's really hard to understand what performance impact you things have. And this way we can ship them to production, enable them for a small amount of users, check whether there's a big performance impact or not, and then slowly increase the amount of calls we do that feature, and keep an eye on the performance levels, right? So as soon as we see something is going wrong, we just roll back. And then the other option we have there is readily enabled for all actors. This is basically what we do when we enable a feature for us, like you guys here. We go there and then we slowly roll out the feature. And slowly people will see, I don't know, sometimes you might have seen this before. You see a new thing on GitHub before we even have a blog post. This is basically what is happening. We usually try to enable this, and then when we're at 100%, we will really stop. Another nice thing we do is we actually have build, which runs all our unit tests and all the other tests we have with all features enabled. This is really important because, as I mentioned before, a feature is disabled by default. So even if you run unit tests, they're not going to hit this code that is written inside this feature block. And by forcing this, we can make sure that if a feature gets enabled on production, it doesn't suddenly break everything. The other thing that really helps us do this many deployments is all the automation we have around deployment. As you remember before, Ubot and Chat are our interfaces to automation, and it's the same for deployments. If I want to do deployment, I go into this center called .com operations, and I just type this command, deploy GitHub my branch to review that first. That will trigger a review lab deployment, and you can see here that Ubot is actually pretty helpful usually, and he will go and make sure that my branch contains the latest code from us. He will merge it in, and then start the deployment on all the CI checks that we have to pass. Make sure that we don't deploy broken code. Here, if I want to deploy to production, like a real production environment, we have something in place called a deployment. We don't want to interfere in a deployment if someone else is currently deploying, so we have this queuing system which allows us to just say, okay, whoever is currently deploying to production, I'll be next, right? And you can see here, when I executed this command, Ubot came back and told me, yeah, you're queued now, and there's one person ahead of you. And once that person is done with their production deployment, I'll be next. And we have again more automation there, like Ubot is going to automatically prepare like a temporary branch which will contain my branch changes plus changes of the other person that is currently deploying. So once it's my turn to deploy, I can just go ahead. You can see here the other person, Eileen, she finished her deployment and Ubot picked me, so I know now it's my turn to deploy. And I went ahead and put deploy to Canary immediately because all their changes, or all the changes Eileen made, were already merged by Ubot into my branch. And then, this is the result of the Canary deployment. You can see it selected 30 servers, and the deployment took around 2 minutes. So that's pretty fast. Once the deployment finished, Canary, for example, we go and monitor the system. One of the tools that we have really to monitor the system is Haystack. I know there's other tools like Rapid Air Brake or Sentry or something like that. This is built by us, for us. And it will basically show you all the errors that happen when you deploy. There's always some errors happening, right? Some system shuts down or whatever. But usually we use this and check against normal error rate. And if there's some inconsistencies and we see, okay, something is burning now, we can just revert back to the master branch that was there before. And in this case, everything is fine, like only a few errors, okay? I go ahead and deploy to production. And again, you can see here that Ubot picked the next person in the queue and told them, you're going to be next. Make sure you're at your computer, and I'll prepare everything for you. Here you can see, like, we finished deploying to production. We have around 500 servers. It takes around 5 minutes to deploy to all of them. And then, usually after the deployment to production, again, check Haystack that really everything is still okay. Because sometimes errors don't happen if you deploy the Canary because users don't do things that might cause an issue. And then if you deploy all of production, you might see problems. And then again, we still can revert because we didn't change the master branch. Once everything is fine, Ubot might ping me and tell me, hey, you can merge now, everything is looking fine. And then I went ahead and merged my change, and I was done, right? So this is the heavy part. Sometimes things go wrong, and people start being angry at Ubot if things go wrong. So not everything is perfect, right? Okay, so this is some of the cool stuff we are doing at GitHub. unfortunately, we don't have a lot more time to talk about all the other stuff. We might have some time for questions. Then if you want to know more, you can always come to us after our talk and talk to us. Also,
and we're hiring people, so we need engineers. If you want to come to us, send us your applications, please. Well, you can apply.
Thank you.